Hello all, welcome back to Chemicals and Compounds, and today we're going to be talking about the four fundamental forces of nature. So, what are the four forces of nature? Well, the four forces of nature are the most common and important forces present throughout the entire universe. They are omnipresent and cause many of the phenomena that we see on a daily basis. The four forces include the electromagnetic force, gravity, the strong nuclear force, and the weak nuclear force. So why do we study them? The four forces of nature are very important in understanding both physics and chemistry, two very important fields of study that make up physical science. They are needed to understand concepts such as electronics and nuclear chemistry. They mediate a large portion of everything that happens throughout the universe. So, now we're going to talk about the electromagnetic force. The electromagnetic force includes two very important phenomena, electric and magnetic fields. They were originally thought to be separate forces, but famous physicist J.C. Maxwell unified them under the electromagnetic force. Oscillating electric and magnetic fields create electromagnetic waves, which are fundamental to many things such as radios, microwaves, electronics, and even light. The current theory is that this force is created by the exchange of virtual photons between charged particles. Now we're going to be talking about gravity. Gravity is a unique force within the universe, and it is the weakest. It is the force that pulls masses together and is thought to have infinite range. It was first discovered by Sir Isaac Newton, one of the most important physicists ever. It is theorized to be created by objects weighing down on the space-time continuum. It is the only force of nature not to fit into unified quantum theory. It is the force that keeps the planets in orbit and stops you from flying off into space. The strong nuclear force. The strong nuclear force is the strongest force in the universe. It is created between the exchange of gluon particles between quarks within nucleons, which include protons and neutrons. It is strong enough to overcome the electromagnetic force, which allows it to hold the nucleus together by stopping protons from repelling each other. Now we're talking about the weak nuclear force. The weak nuclear force is the second weakest force. It allows protons to become neutrons and vice versa. It allows radioactive atoms to go through beta decay, which allows their nuclei to reach a more stable state. It is mediated through W and Z bosons. And that is the end of this video. Thank you for watching, and hopefully you learned something.